My name is Max, and I do lots of random things in my life. There's a globalmax.net website where a collection of those things. One of them is software development and IT. I work in this industry about 10 years. And I started be interested in all of that when I was like 14 years old. And computers were big and the programs were small. The memory was extremely expensive and CPUs were very slow. And that actually helped me to develop specific mindset. And when I look at the code, I always think, okay, how it can be as efficient as possible. So recently I work a lot with Ruby and Rails and databases. So I have a collection of things that I see pretty often happens and can be improved tremendously. It works for Ruby, Rails, or pretty much anything. It's more like concepts you need to think about. So I wanted to start with asking you, like, what do you think, like, 3 top reasons for something to be slow? Any ideas? Go ahead. And, okay. Anything else? It's a good one. Yeah. Okay. I'll give you a hint. It's software developer. It's usually the number one reason. There are a couple more. There's software engineer and programmer. These are 3 top reasons. They're usually the most responsible people. And a reason for that, technologies are different. Like you can put big formula and C will calculate it faster than Ruby. There are lots of holy wars online about what is faster, lots of tests. And the thing is, it's all relative. In real life, final impact is made by the person who actually writes the code. And this is very important to keep in mind. This is another thing I'm not going to talk about today. I just want you to understand this thing. Sometimes people say, oh, just throw more CPU or memory or do load balancing and things will magically work faster. The thing is, load balancing is to handle more users, not to cover up inefficient code. So if you have 1 million users, it's a good problem to have. If you have just a couple of them and things work slowly, it's not about users. So don't even think about this. If you have 10 servers that answer for 6 seconds, and it doesn't matter if one answers for 6 seconds, it's too long. It's a bad user experience. And also a big reason is load balancing increases complexity. You need DevOps department, a lot of other things. And again, if you have many millions of users, it justifies the price. Otherwise, you better off look at your code and figure out how you can run everything with one server. And even if you balance, it's still a good thing to consider. Number one thing I'm always look at is so-called red flags. There are specific things, and you need to develop it through experience that should start you worrying, like something is fishy here. Another thing, when you look and you have this feeling, okay, something might be wrong, you start thinking about this, and then you start digging and learn what actually happens. So when you first learn some language, you learn syntax. And then after a while, you start wondering, okay, what actually going on? And you might want to go and look like, what does this function actually does? And it's really helpful because eventually you start to understand, okay, some things do something not obvious, and then you eventually start to understand what's actually going on. The one most dangerous thing I ever seen is one-liners. They sometimes very beautiful, very readable, but sometimes a lot of fishy things going on. Because they're so simple, they usually just, everybody looks at them, oh, it looks amazing, and nobody pays attention what's actually going on. Simple example, I'll get an array of animals. That's what I'm going to work with. It's lion, it's yellow, it weighs about 420 pounds and runs. And basically all this array is animal, what its color, its weight, and what it usually does. And it's good. You have a million lines of like that. And you just want the ones that fly and lightweight, right? And you just write beautiful one-liner. It selects the ones that fly. It finds all that less than 10 pounds, and you just get their name. So easy, so readable. It's pretty obvious what's going on. And then you start thinking, like, probably it's going to run through all animals, going to run these conditions that it equals fly. Then it's going to get that array, run it a second time through find, and then it's going to run it third time through map. At the same time, besides the first array, you have 2 more arrays in memory, and you keep running through them. And this is where you should start feeling like some weird things going on. It can be easily written as a simple array. You just make everything you need in one iteration, and you're pretty much done. Still readable, not as beautiful as one-liner, but that actually works probably 3 times faster and consumes 3 times less memory. If you keep thinking about this, even that can be improved if you think about the whole picture, what you're trying to achieve. If you're giving this array and you actually try to extract some records based on specific criteria, you can consider actually changing whole structure. Sometimes you can substitute one thing for another depending what you're trying to achieve. It's like you're trading CPU for memory depending what you're dealing with, size of things you handle. And the same thing can be written a little bit differently. You can create different structure that will separate all your animals into 2 categories. Lightweight, heavyweight. You also take A3, which is their weight. You put it into hash, and then you have the structure in memory. This case is if you don't have key yet. And as simple as that, yes, this structure is going to occupy a little bit more memory. At the same time, when you need something, you get it just from one line. You just get it from hash. Everything you need to do is just to write cycle that fills out the hash. Depending on what you're trying to achieve, that can be an option. If you're going to reuse that structure many times, it saves you a lot of resources. Once you have that, you can extract as many records you want based on their weight and what they like to do. So these are very common things that I see. There are lots of others, but this is what I really like to pay attention to. Sometimes it gives you huge benefit in performance. And that actually reminds me something. You have structure that has key, and it's a lot like the database. That's what database do. You put data in it, and it just creates keys, and it can quickly find something for you later when you utilize these keys. Talking about this active record, I like it. It's pretty amazing if you know how to use it, because the biggest concern that I usually see is between these 3 functions. They work very differently, and depending on circumstances, it can be just productivity killer. So I'll get back to them a little bit later in detail, but I just wanted to state in your mind that you need to figure out what they do and when you need one of those. Another big thing is lazy versus eager loading. When you have a relationship, let's say on this picture you have accounts and suppliers, you get accounts, and then for these accounts you want suppliers. Depending how Active Record loads it, if it's lazy loading, it's going to get accounts, and when you iterate over them, it's going to make single requests to database to do this. If you do eager loading, then it's going to get all of them at once, and when you iterate, they're already available in memory. And it saves a lot, depending on what you do. Again, if you just have a couple of accounts, maybe not a big deal. If you have 1 million, you don't want to make extra 1 million requests in database for no reason if you can get them at once. And another one, batch updates. I don't know if it's currently part of Active Record, but it's definitely gems that can do this. Same thing, when you update something, you don't have to do it one by one. You need to update lots of records. You can just throw a huge array, and there's a gem that can process and put it in one request or several into the database. A little bit about SQL, even though it's not Ruby, still you usually, if you do web development, you touch some kind of SQL database. And this is how you probably want to use it. If you have animals and you want the one that bird, and you just want name and its color, you want to use plug. Plug just going to give you array. All other possible functions give you array of active record objects, which is much heavier structures and going to work slower. And on small scale, you will never notice it, but on a big scale, it starts to be very noticeable. Sometimes I've seen things like you do animal, where bird, and then you do map, and it means it's going to run through all these objects in memory, then it's going to call these accessor methods and then going to put it in an array. It's just extra work for absolutely no reason. If you do select, it's a little bit better. It's going to grab less data from database, but still, if you want to iterate over and use accessor methods for no reason, it doesn't give you any benefits. Plug gives you plain Ruby array, and if that's what you want, this is how you use it. Another thing, join versus subquery. Active Record handles it behind the scenes, and it's very useful to look into log and see what request it actually does. If it's quite complicated and you have joins, you can go to database, and sometimes subquery can be faster, sometimes join. You sometimes will want to poke around with the request and see if you can write better request, and then you can translate it back to Active Record. The biggest friend is explain. It probably exists in every database that's out there, and it tells you what database will probably do. And you can see some big iterations that it will try to run, and it will give you some hint that probably it's not well written. And number one reason usually something is slow or will take some time, and explain tells you about this is indexes. Again, it's not Ruby, but since a lot of web developers deal with database, it's something to know that these things exist. You need to learn what they do, and they really can improve performance of your database request if you utilize them properly. So this is just something to keep in mind. I don't want to go into details. It's just something to memorize and go learn later because it's extremely helpful. How hard is that? Well, if you try to write perfect code from the very beginning, it is hard. So what you can do instead, you write ugly code, then you read it, then you improve it. So this first one-liner I mentioned looks pretty good, but then you start think, and you rewrite it, and maybe you write it another one time. It's totally fine. Like, don't try to be very perfect first time, because if you have idea in mind and you would just want to put it in there, you just want to do it as fast as possible. And then you can go and improve it. You can even test. If you write something down and it runs fast, maybe why bother? But if you immediately see it slow, you might start thinking about what's going on. And this is another point. Just make things work, and then you can, through many iterations, just improve it. Moving forward, especially good to know for web development, this very good thing called cache. You can have quite slow things on the back end, but if you cache, it doesn't really matter. If user gets fast responses, you can deal with that. And there are lots of options. A lot of databases have cache in them, and there was a job a long time ago. It was like database architect or somebody. I don't know if they're around these times. Recently, what I've seen, just web developers have to deal with that. And there are managed database services, and sometimes you set it up manually. And default value is not always the best. So there are different ways how different databases caches, how much memory they reserve for query caches. And you probably want to read a little bit about this, because database can do a lot of work for you. Even if it's slow request, it runs it once, but second time it's going to answer much faster because it already keeps records in memory. Another place is UI. Browser obviously do it. You can set up web server to do it. Again, it's kind of area of not developers, but as web developer, you sometimes have to deal with that too. You need to understand what options are there. And obviously, backend Rails have pretty amazing functionality for that. The fastest request is never performed request. So if you can do this, then it can be very, very efficient. A couple of examples is CDN, example of great UI caching. There are lots of third-party services. So instead of your web server that optimized for Rails application trying to serve images and JavaScript and CSS that probably going to stay there until at least next release, there are CDNs. They serve assets, cache them, and do it really fast from locations to usually really close to users. And usually it's really automated. Every cloud service have them. You don't have to worry about anything. You just specify where your actual files, it grabs them, caches them, and Rails have a lot of functionality that handles all of that automatically. It substitutes URLs properly. Amazon S3, I'm sure other cloud services have same things. It's more for bigger files. Again, you might not want to deal with big files on your servers if you want to give it out for clients. S3 does it pretty well, and many other things. You can even put your website on S3 and it's going to work. It's quite incredible. And Rails caching. You can cache whole action just in the beginning of a controller. You say caches actions, you specify actions, and they're going to be cached until it expires. Sometimes it doesn't really work when you cache whole action because different user can have different data. So you can cache part. You can cache piece of code. Things here depend on cache key. So for every user, you can have different cache key, and depending what's your code inside, they're going to see different responses. But only first time, it's actually going to run the code. Second time, same user comes back, it finds same cache key, and it immediately returns results without rerunning the code. It's pretty awesome. And another way of doing something, if you do update, you can go and just delete it. Obviously, you set some expiration time, but if for some reason you do release, there are rake tasks to bust the cache, or if you update some data and you want user to see refreshed information, you can just go and delete specific key. It requires a little bit playing around, but eventually you can see how it improves things. If you come in first time and never see anything slow after this, pretty awesome. But what if you don't even have to see first time slow request? This amazing thing called cached warming. So even before user comes in and hits some page, you can actually recreate cache. And it can be done as easy like this. So the only difference between this and previous example is force true. So you do this in some rescue or rake task. In this case, it's just going to hit some URL that has API response. It's going to get hash. And even before when user comes in first time, it already have this hash in response, and then it's not going to rerun anything that's behind this warming URL API. The way I use it, it's just a rescue job. It can run every morning before even users comes in. They already have most popular pages cached. A couple of other tools to consider. Database use. It's special tables that aggregate data from other tables, and instead of writing complicated join request or anything, it can be already in database in some table. And Cassandra is a very special case. It's a specific database to just do that. You do a lot of complicated requests in your database, you extract this denormalized data, put it in Cassandra, and it's just going to deal with this. You cannot even do joins in Cassandra. It's specifically for these huge denormalized tables when you just need one row with all information. And from my experience of dealing and being admin of databases, it's extremely easy to deal with. So much easier than anything else, and it has replication. And another thing is periodic jobs. Not everything you actually need, you need to do in controller. Sometimes you can pre-calculate things. Sometimes you can run some nightly jobs. It doesn't have to interfere with what users do while they are on a website. And another thing is jobs on demand. When users comes in and they want something, depending on user experience, it's not necessarily should be immediate response. They want some file, it will take you time to generate this file, and you can just say, look, it will come in your email. And you queue rescue job or Sidekick, and it later comes in an email. Depending, sometimes things complicated, and you actually, no matter what, have to take time to run something in the background. So that's a pretty easy option. This is something that you need to be strategic about. You need to see, okay, whole picture, what is user experience, what you're trying to achieve, and you just need to find the best tool for your job. It's a lot of things. I wanted to give a little bit of overview. All these things you have to keep in mind simultaneously, and when you write your ugly code and want to improve it, all these things you have to think about. Again, one-liners, sometimes they're amazing, sometimes they're dangerous. Array versus hash, how you handle these structures, what's the best suitable structure. There are many others, but these are basic ones to consider. Sometimes arrays and hashes becomes too big. You start using database, active record. You need to know what the best way to extract data from there, what's the most efficient way to run batch requests using active record or even pure SQL, and how it loads, how you update things. Cache everything, absolutely, possibly you can think about. There's absolutely no need to rerun same code again and again. Learn databases, learn how to aggregate data, how to prepare data before you even serve it. There are lots of opportunities usually for that. And think about delayed delivery. Sometimes immediate response is not necessarily what you want. So just 6 things to start with to keep in mind. And good luck writing code.